Created in 1983 by CEA and ADEME, GRETh combines CEA's research capabilities and ADEME's policy for technological innovation in the field of energy.
GRETh was specially set up to promote technology transfer between research and industry.
The main objective of GRETh is to foster the field of heat transfer. Industrial technical research centres such as Cette and Ensuite have now joined CEA and ADEME in this effort.
GRETh can be considered as an industrial federation. Its membership reaches around 100 French and European companies, mainly small and medium-sized firms. Before GRETh was created, VCARB had been familiar with the work done at CEA Grenoble since the 70s. At that time, managers of heat transfer laboratories realized that these skills could and should have been used in industry. The fact that GRETh has such a big impact on its industrial partners and that its programs really fit their needs means that the academic collaborators of GRETh can orient their research activities according to well-defined industrial needs. This is obviously quite an efficient scheme for technology transfer.
A recurrent concern of GRETh scientists and engineers is the diffusion of knowledge throughout the industrial world. As a member of GRETh, one is entitled to receive the GRETh Technical Handbook, which is constantly updated with the latest research, specific heat transfer softwares.
Software packages are made available to members for comparison with the capabilities of their own heat exchangers determined in their own laboratories. When we are developing a new type of cooler, we use mainly the CTUC software, which enables us to simulate the influence of certain parameters on the performance of this new cooler.
Improving the compactness of thermal equipment is important in many industrial branches. Numerous techniques are now available to improve heat transfer rates in both single and two-phase flow conditions. Heat transfer involves complex physical mechanisms, but in all cases the knowledge of the flow field close to the walls is an essential factor in determining the optimum geometry for the equipment. Phase change phenomena such as steam condensation are frequently encountered in industrial equipment. The research programs undertaken at GRETh concern the condensation of pure vapour or mixtures and are aimed at optimizing the condensers used in various industrial processes.
I think the main advantage of GRETh for us has been its ability to make measurements of thermal quantities in these improved tubes, since we are not equipped to do this ourselves.
In this area, the research goal is to determine original high-performance geometries which increase the thermal efficiency and reduce the size of a heat exchanger. These phenomena are encountered in the chemical and petrochemical industries and in refrigeration facilities. Correlations and models are also being developed for calculating heat transfer coefficients and pressure losses. Progress is also being made in characterizing and understanding the complex two-phase flows occurring in industrial evaporators.
We also help industrial companies to define their needs clearly. Our partners also appreciate the fact that not only do we work in real operating conditions with the actual fluids, temperatures and flow rates, and therefore the real heat capacitors, but we also provide results in non-dimensional form rather than raw data.
is cleaned by using some special industrial equipment such as scrubbers or absorbers, which bring a liquid phase and a gas phase into contact. It is important to separate the two phases as much as possible in order to minimize atmospheric emissions. As a result, it is essential to study in depth the phenomena governing the droplet entrainment in order to properly design the devices for phase separation. To guarantee the high level of thermal performance required for evaporators or condensers, two-phase flow must be distributed as evenly as possible in the entrance and between the various passes.
In my view, GRETh's main asset is its superb experimental facilities. This centre has succeeded in developing and maintaining a series of test rigs which can be used to carry out quite remarkable experiments.
In industrial operations, it has been shown that the level of energy consumption reaches a peak when the temperature of a process is around 1200 degrees. In this temperature range, heat transfer surfaces are made up with ceramic materials. When heat transfer is governed by convection and radiation, various layout and flow configurations are studied in detail. Fouling is a major technological problem in energy control.
As plate exchangers are compact exchangers, we're trying to solve some of the problems, such as fouling in particular, that restrict their use.
By reducing fouling, equipment operation and reliability can be optimized, leading to a significant decrease in the operating costs. Corrosion is another difficult issue in industry. Plastics provide an interesting solution since they have a high level of resistance to corrosive agents and are light and inexpensive. Graphite, which is widely used in the chemical industry, is also very resistant to corrosion. Many sectors of food industry are using evaporation techniques to concentrate liquids. These concentration techniques are also widely used for processing and recycling various types of liquid wastes. All these processes are being continuously improved by using original geometric configurations.
GRETh does a very important job by maintaining a technology watch. It's also a team of heat transfer specialists paying particular attention to our needs. A meeting point, a melting pot, a forum for exchanging ideas. GRETh's reputation as a centre of technological resources means that we can look to the future with optimism.